Assalamu alaikum. Welcome to the next lecture. Today we'll be doing or we'll start from the typical wiring layout at home. Let us start with this. Let us first make a block view of the home and try to differentiate the different rooms. Let us say this is bedroom 1, this is veranda, this is a kitchen, this is master bedroom, this is bathroom, this is a dining area, and this is the living area. So we'll assume that we'll be having different MCBs, and different MCBs are used to protect oneself from the short circuit. So we have a single two-pole MCB and an RCCB, a single pole MCBs. These are 7 for this case, and we have this neutral terminal bus bar, and we have ground bus bar, or it is also known as earth terminal bus bar. So I'll first come to the bedroom 1, and in this bedroom, let us say we have two switches. They are also known as one-way gang switch. We have a fan dimmer or fan regulator. It is also associated with a switch, its own switch. We have a socket, and socket as it is own switch. It has own switch as well. We have a fan in this room, and we may be having two LED bulbs in this room, or any type of bulbs. It can be LED, it can be CFL, or it can be incandescent lamps. So this is for the bedroom 1. Similarly, we'll be having similar type of equipments in this dining area. A switch, a fan regulator, a socket, fan, and a lighting point, or CFL. A kitchen, that we have a different more heating loads in kitchen. That's why we will be having two sockets over here. Rest may be same. We might have included the fan, but I have here it has not included the fan. Similarly, master bedroom, similar to that of the bedroom 1, one fan, two bulbs, and two switches. For bathroom, we have a socket for heating point and two switches. One is outside the bathroom, lighting point outside the bathroom, and another lighting point is inside the bathroom. And for the living area, we might have one light point, one socket, heating point or some charging point, and two-way switch. This two-way switch, one switch for this bulb, and the switch will be for a lighting point at the veranda. So we'll start having two wires. One will be the live wire denoted by the red, another will be the blue wire, which will be denoted by the N. One more thing that I first explain over here, we have this is a two-pole MCB. It means this MCB is connected to the both live and neutral wire, and these are single pole MCB. It means these MCBs are only connected in the live wire, not in the neutral wire. Now this is RCCB. It is connected in series with the two-pole MCB. You will see this point will be connected to this point will be connected to this, and then output will be taken from here. This actually used to have extra protection in series with this. These MCBs are used to protect the circuit from the short circuits, or we can say dangerously high currents. But this is used to protect uh, the residual currents. If there is a current that is flowing from any equipment to the human body, this will be tripped, and in that case human body will be, or human will be saved. So RCC means residual current circuit breaker. So in that case this is very useful. Now let us move further ahead. You can see this is connected to this point and this is connected to this point. So in that case, then these are all connected to, these are all connected to positive terminal or live wire, and this is a neutral bus bar. This is a neutral bus bar. From here, bus bar means a connection from which different connections can be taken. A single connection or a single conductor from which different connections can be taken. That's what is meant by the bus bar. Similarly, this neutral has to be connected to this bar, so that because every component or every appliance needs a neutral, that will be taken from this bus bar. And there may be some three terminal devices, like we have this, we have a third terminal device. It will be connected to the ground, and I would already discussed the importance of the ground. So this will be connected over here. So these all will be connected to the positive terminal, and its positive terminal will be then taken from this. Now this will be connected to the switches, other terminal will be connected to the bulb. So this is also connected to this. That means this circuit breaker will be used to protect this bulb and this bulb, because you can see this bulb and this bulb are controlled by these two switches, and they are protected by this MCB, because they both get the power from this. And then the neutral wire has to be taken from the neutral bus bar to connect this and to connect this. You can see it from here. It is doing the same thing. It is connected to this, and then other point is connected to this point. And this case, this circuit is completed. Now coming to this, this is a socket, and it has its own switch. That means it's one terminal, whether this or whether this. In this video you will see that this terminal is in series with this, so that uh, this whole socket will be controlled by this switch, and it will be protected by this MCB, because it is connected from here to here. And you can see this is connected to the live phase, and this is connected to the neutral phase, and then this will be connected to the ground phase. This is how a socket is connected. Now coming to the bedroom, first it will connect a switch this, and then it will be connected this switch to this bulb. Similarly, this switch will be connected to this bulb, and they will get the same supply from this connector. And then the neutral through this to this, and from this neutral it will connect to this. Similarly, for a fan dimmer or fan regulator, you can see from here it gets this phase wire or live wire to get connected to this switch, and this switch output gets to fan dimmer, that is usually circular in the shape, and then its output will go to the one of the terminals of the fan. And you can see it will be connected to one of the terminals of the fan, and the second terminal will be the neutral one. So, and the third one will be the ground one if it is present there. I'm assuming to be the safest way that there is third one present also. Now this is for the socket, and you will see that the connection of the socket has been taken from this wire, and I have told you that it is using this separate MCB for the sockets, and it is taking the connections from the same MCB. It is from the neutral wire, and from here it is a ground wire. So this is for the bedroom first and living area. Now coming to the dining area. Only two MCBs has been used, and it will use separate MCB, because the protection will be then separate to the switch of the bulb, and then its output to the bulb. From the neutral point it will get its neutral point as well. You can see this is the neutral point, and then for the fan it is the same circuit from the same MCB, and neutral from here and ground from here. Now be careful, you can see from here it is using another MCB for this socket, so that there is a different control or different protection for this socket and for these two sockets, and then ground wire from here. And by using the similar notation, it can uh, connect all these components in kitchen, in master bedroom, in bathroom, and I will not go to the explain, but I will just play this video as it is, so that it will be quite easy for you to understand. You have understood this. The wiring layout of the home. You can use see different videos which are available in the at the YouTube or any other platform. So this video has been taken from the YouTube so that it makes understanding a bit easier to you. Now coming to the specification of the wires, you might have used or seen different wire which we use at our house, and they have different types of or different cross-sectional areas. One may be thinner, another may be thicker, and based on the cross-sectional area we differentiate different wires. Now I'll be there are different nomenclature. I'll be only concentrating on this column and on these two columns. I'll try to explain others as well, but this column and these two columns are very important. For example, if we have a wire uh, whose dimensions, that is cross area, is given as 0.5 square mm. So in this case, the number of strands will be 16, and diameter of the diameter conductor strand will be equal to 0.2 mm. So insulation thickness will be 0.6 mm. Overall diameter will be 2.1 mm. So it is conduit or trunking current rating will be equal to 5 ampere. It means when it is, or we can say when it is installed inside a wall, because there the dissipation of the heat when current flows is slightly less because of the closed area. In that case, the current rating will be like this. And this is unenclosed clip directly to the surface or cable trays, or we can say this is directly outside these conduits or trunking areas. There the surface for the dissipation of heat is available, and it can bear a current of 5 ampere continuously. This is known as current rating or current carrying capacity. Two cables single phase. This is actually a specification for uh, given for company. Which one is this? It is Havells company. I not mentioned over here, but I have taken this data from the Havells website, and the voltage rating of all the wires that we are using in our home, it will always be 1100 volt. So usually the normal voltage that we get, that is actually 230 volt, but the voltage for this insulation, that is the wires that we are using at our home, their voltage breakdown capacity is around 1100 volt. So the maximum conductor resistance per kilometer will be 39 ohms. So this is the resistance of this conductor or this wire, which is made of this cable, or we can say this wire of 0.5 square mm diameter or area. Similarly, for 0.75, it is conduit conduit rating or current carrying capacity is 10 ampere, and outside that, or when it is exposed to the surface environment or atmosphere, it is 11 ampere. Similarly, for 1 square mm, it is 15 ampere or 16 ampere, and for 1.5 square mm, it is 18 ampere and 22 ampere, and for 2.5 square mm, 25 ampere and 28 ampere. 4 square mm, it is 35 ampere and 42 ampere, and 6 square mm, it is 46 ampere and 52 ampere. This is very important because based on this data we can see which current or which uh, wire that we have to use in our day-to-day life or in our housing wiring diagram or room wiring diagram. So usually in a normal house, 6 square mm is sufficient, because you can see this 46 into 230, it comes out to be 10.5 kilowatt. So if a house or a home has a 10 kilowatt load, 46 amperes will suffice. That means 6 square mm will suffice. That's why for this case I have only mentioned up to 6 square mm. But if the load increases, that means here we have 10 square mm, its current rating is 59 amperes. This is, it shows only unenclosed outside the home. because usually when you use inside the home, the value of these will suffice, because underground cabling or underground fitting, that is usually known. For that case, the load will not go beyond 46 amperes. And when the main wire is considered, that is usually outside the house. That's why that is unenclosed, that's not closed somewhere in the walls or anywhere else. That's why it only shows one column of that. So 10 square mm 59 amperes, 16 square mm 79 amperes, and 35 square mm will be 93 ampere current carrying capacity. Up to this, usually personally I have seen um, uh, that some homes have installed, or some houses has installed, a wire of 25 square mm, and their load carrying capability or current carrying capability is about 93 amperes, and this 93 amperes means around 21 kilowatt load. They might have this much of load, that's why they have to install 16 square mm as the main, sorry, 25 square mm as the main conductor or main wire. So you can use this data to design different types of wires, and as per this you can install these wires. Now, specification of the sockets and plugs. So in general in India we have voltage rating will be 230, or sometimes some parts may be rated as 220, and frequency will be always 50 Hertz. The current rating of these plugs and sockets will be of 15 ampere, 5 ampere, 15 ampere, and 25 amperes. So beyond this, these type of sockets are not used. There are other sockets which I will not go into detail, because their rating is higher and their configuration is also different from this, and you might have seen at your home these type of sockets we usually come across. So we have usually three types of plugs and also sockets. Type C plug is this, where we have only 2 pins and 2 sockets. Type D, we have 3 pins and 3 holes in the socket, and this hole will be slightly bigger as compared to these 2 holes. Sorry, type D. In this case, these holes will be slightly smaller as compared to this. This is for ground. These two are for phase and neutral. Similarly, for type M, it is similar to that of this, but only thing is that its current rating will be higher, because these 2 holes and these 2 pins will be slightly thicker than that of the type D. This is the only difference between this and this. And you will see that the hole which is used for the ground will be bigger as compared to the other 2 holes. This is also for the protection purpose. You can see that if this hole is bigger, this pin will also be having a larger diameter as compared to these 2 pins, and if you try to insert this ground pin into this, it will not go inside this. So in that case, you will see that if this pin which is at the ground potential is connected to this, there will be a sudden, you can say, phase to ground short circuit or fault. So this is used to avoid that fault. For this case, this is also used for the same purpose. So these are the different types of the plugs and sockets with different types of rating that we usually use at our homes. So you need to remember this, because when we calculate the load of your room or your sometimes house or sometimes at the balcony, so looking at the load, you will calculate the current, and as per that current, you can select which type of socket you or plug you have to use for that appliance. And we will try to do the same thing. Now, selecting the particular wire, socket, and plug. Let us see how to select a wire or a socket or a plug. So let us take an example of a room, and let us say we have two incandescent bulbs. I have started from an incandescent bulb. I'll let you know why. We have a fan, a blower, and an iron to be used as a load in this room. So what is the load? We have two incandescent bulbs, we have a fan, we have a blower, it's a heating load, and we have an iron, or we say that is uh, in a common language it is known as press. Obviously you will see that in most of the times they will be rated for 50 Hz frequency and 230 volt voltage. Sometimes they may be rated to 20 volt voltage as well, but frequency will always be fixed for 50 Hz. And power rating is also given. You will see that these two will be almost constant, and with some we can say with some having a 220 volt rating. Other power rating will depend upon the how much power it will take. It will be different for different equipments. The power and current rating will be different. Let us say we have a bulb of 100 watt and its current will be, because when you divide this 100 by 230 volt, its current will be equal to 43.4347 amperes, and for two bulbs it will be equal to multiplied by 2.87 approximately amperes. For fan, which is usually of 70 watts, it is usually from its wattage will vary from 70, so 30 watt to, which is quite energy efficient fan, to 100 watts. I have taken some between value from 30 to 100 watt. Let us take it as 7 watt. Its current will be equal to 0.4755 amperes. I will let you know how this current can be calculated. For the time being, let us assume that it is given that its input current to be taken will be 0.4755 amperes. Similarly, blower, I just have divide this 2000 by 230 volt. It comes out to be 8.7 volt. And for iron, which I have told you that its common name is press, its wattage will also vary from 1200 to 1700. I took it as 1300 because the iron that I possess that has this wattage 1300, its current is calculated as 5.65 amperes. Now the total current supplied will be the summation of the total current to be equal to 0.87, 0.477, 0.4755, 8.7 and 5.6. It comes out to 15.6 amperes, 7 amperes. So from this table, the 15.6 ampere would have been 1.0, but it is not good to use this for 15 point because its current rating is only 15 amperes. I use here 1.5 square mm because its current rating is 18 amperes. So that means I have to use the main wire for my room as 1.5 square mm. So 1.5 square, and it will suffice for my room. But for protection purposes and for the safety purpose, and sometimes you may be using more heating load, and in that case you will not replace your wire at that time. You'll take that into consideration and install a wire which is slightly having more capacity as compared to the actual that is present at this time. That's why usually you will see in practice most often or mostly 2.5 square mm is used for a room to have more safety. But don't go beyond that. It is 2.5 square mm is quite sufficient. So the total heating load, you'll see it comes out to be 15.35 amperes. That is these two. These two loads are very smaller. So if you have to use a socket for the heating load, because when you use a socket, in that socket you can use the charger, you can use the heating load directly by using some extension as well. So by selecting the socket, you first have to consider this. That means therefore the socket that is to be using for this heating load should have been of this rating. But and more preferably DRM, that means 3-pin socket or 3-pin plug type. So in this case, this will be quite safe to use the socket of rating 25. But you might have seen that in our homes we usually use only 15 ampere rating of the socket. We rarely use this 25 ampere rating of the socket. It is because in case of heating load, when voltage decreases, current also decreases. For the case of, let us say, this heating load whose wattage is 2000 volt for a voltage of 230 volt. If the voltage gets half, this current will also be half in that case. So when the current is half, the total current that is to be supplied will be very smaller as compared to this calculated one. In that case, 15 ampere also will suffice, because when the voltage is exactly equal to the rated voltage, the current is just touching the current carrying capacity of the socket. But when the voltage is half, current will be half. This will suffice. 15 ampere socket will suffice in that case. But for the protection purpose, you should always use this type of this socket, and you should use the wire of this dimension of this area. So this is how you select a wire and how you select the rating of a socket. But first you need to understand how much load you will be using in your room. Now let us come to the features of various domestic electrical appliances. So the feature is their electrical, you can see, rating. The rating, there are different ratings, but we'll only be considering the electrical rating. There will be usually three electrical rating which will be given for every electrical appliances. That is the voltage, that is usually 230, and some may have 220 volt, and frequency will be 50 hertz. Power rating will be depending upon the size of the motor, size of the equipment, or type of the equipment. So from these above three quantities, usually we are using these two quantities, the current can be calculated, and based on this current we can select the wire, or we can select the different type of sockets. So the calculation of the current for domestic electric loads, single phase circuits, we know that power is equal to VI cos of phi, or VI into PF, where PF is the power factor. So from this equation, current will be equal to P divided by V into power factor. But for electrical motor, usually power that is given, that is the output power, and we need to calculate the current from the input power. Output power and input power are related by the efficiency. So this current will be actually equal to input power divided by voltage divided by power factor. But this power which is given, that is output power. So input power can be given by this output power divided by efficiency. So there will be slightly different relation or formula for the motors. Its current, that is the current, will be equal to P divided by voltage multiplied by power factor, and it is to be multiplied by efficiency in the denominator as well in case of motors, so as to get the input current for motors, where N is the efficiency of the motor. And efficiency is nothing but the output real power divided by the input real power. So why is it important? Because their usual ranges are known for in practice. You can see the values of power factors. For heating load, it is always taken to be equal to 1. For transformers, it is taken to be 0.9 to 0.95 because it's a static device. And for electrical motors, it is to be 0.8 to 0.85. And efficiency for electrical motors is usually taken to 0.75 to 0.85, or we can say 75% to 85%. So these values are not usually given, they are to be taken from these values, or we can say it is from the experience that we have taken their range like this. For three-phase circuits, we know that P is equal to root 3 VL IL cos of phi, where VL and IL are known as the line voltage and line currents. Similarly, this should have been also root 3 into VL IL P, so F is the power factor. Please try to correct this. So IL will be equal to P divided by root 3 into VL into power factor for in general. And for electrical motor, it will be equal to, I have here also forgot to mention, it is root 3. I is equal to P divided by root 3 VL power factor and efficiency for a three-phase motor. Please try to correct over here. I might have copied it from the single phase and forget to write this root 3 and root 3 over here, and VL, and this is IL over here. So please try to correct this. Again, these values will be same for three-phase motors as well. That is the value of power factor and value of the efficiency. Now coming to the electric iron, this is actually the nameplate of the electrical iron I have, which is present in with me. So it is given like this. You can see the wattage is given as 1300 watts and voltage is given as 240 volt, and frequency is given as 50 hertz. So by using these values, since it is a heating load, we know that power factor is equal to 1, I is equal to P divided by V into 1, that is 1300 divided by 240 into 1. Its current that is taken by this iron or press will be 5.4167 amperes. This is why how this current can be calculated. This is one electrical appliance that we have at our home. We may have another one, that is rice cooker. So the nameplate of rice cooker is like this. Its voltage and frequency rating is 230 volt 50 hertz and rated power is 1000 watt. And when I calculate its rated current, it comes out to be 4.35 amperes. That is 1000 divided by 230 into 1. That is power factor, and the power factor for heating load is 1. Similarly, for water heater or geyser, or simply the boiler that we have, So the geyser, it usually nameplate rating looks like this. This is capacity, this is rated pressure, maximum water head. So you don't have to go to this. So what we are interested in, that is the voltage, that's 230 volt, that's the frequency, it is single phase AC and 2 kilowatt. And from this formula, you can see that P divided by V into power factor 2000 divided by 230 into 1, it will take 8.7 amperes when 230 volt is given. For induction heater, it's actually an infrared cooker that we have. I have taken the photograph of its rating, nameplate. Its rating is 2000 watt, that's the power rating. Its voltage is 230 to 240. If the voltage changes, it will work well from this to this, and frequency is 50 Hz. So while calculating the rating power, I have just taken 220 volt. I can take any value from this to this. By taking 220 volt, I will calculate the worst case condition. This is the highest current, because when I divide it 240, this current will be less. So you should always try to design for the worst case condition. In this case, it will be. So here also it's a heating load, but induction heater or infrared cooker, its power factor will not be equal to 1. It will be of the order of 0.9 or 0.95. So I have used it over 1. You can change it, and to calculate its current, you can change it to 0.95 and see what will be its current. So this is for the induction heater. And now domestic water pump. You can see its nameplate rating is like this. It is usually given in horsepower, and this power is at its output, that at its shaft. So it is first converted. It has to be first converted to kilowatts. It is done. Uh, it is already done. It has taken it to be 0.37 kilowatt. But most of the motors, you will not see the conversion. You will only see the horsepower rating. Maybe 0.5, maybe 0.25, maybe 1, and its voltage is 220. I don't think their yes, frequency is given or not. No. Yes, frequency is given. It is single phase AC 50 Hertz. This is insulation class. This is something else. You don't have to go for that. Now we'll calculate it as current. I told you that this P is the output power. I have converted actual value 0.5 horsepower. I have converted to kilowatt. It is the approximate value. It is 0.37. It is actually 0.37285. I have used the exact value. So divide by 220, its voltage rating, multiply by 0.8 is power factor that we have taken from the experience, and efficiency. I have taken efficiency to be 0.8, 0.75 to 0.85. I have taken the value of 0.8. So it comes out to be 2.65 amperes. You can see it is given this current will be equal to 0.8 amperes. So it is very close to this. This is how we can calculate it as current rating. Today I will be discussing only these much of electrical appliances. I will continue in the next class, inshallah. Thank you.